concept in this chapter, and that is force acting on a current carrying conductor placed in a magnetic field. Let's understand this. For this, suppose I take two horseshoe magnets, and these two horseshoe magnets are placed in front of each other. Now what is going to happen? These magnets, both of them would experience a force, and when they experience a force, force causes motion, and therefore both these magnets would experience motion. Similarly, if a current carrying conductor is placed in a magnetic field, so here I have a current carrying conductor and it is placed in the magnetic field of that horseshoe magnet. What would happen in this case? The current carrying conductor behaves like a magnet. So again I have a situation of two magnets here, and because of this, this causes motion in the conductor, and this conductor would experience motion. This is called force acting on a current carrying conductor placed in a magnetic field. Now let us do an activity to understand force experienced by a current carrying conductor placed in a magnetic field. For this activity, what I do is I take a small aluminium rod. After taking this particular small aluminium rod, suspend it on a stand using connecting wires. After suspending it on a stand using connecting wires, connect it to a battery and plug key in series, as you can see in the circuit diagram. After connecting a battery and plug key in series, I bring a horseshoe magnet. So bring a horseshoe magnet in such a way that rod lies between two poles of the magnet. Or you can also say, now the rod is placed in the magnetic field of the horseshoe magnet. After this, as the current is flowing, it is observed that the rod experiences a force which sets the rod in motion. And this rod, it is observed that the rod gets displaced to the left, or you can say it is displaced outwards. Now, next what we do is we reverse the direction of current by changing the polarity of the battery. Now, when the current flows in the opposite direction, it is observed that the rod now gets displaced to the right, or you can say the rod is displaced inwards. From this, our conclusion and our understanding is that we understand that the direction of the magnetic field, direction of current and direction of motion of the conductor are related, and the relationship between the direction of magnetic field, direction of current and direction of motion can be understood by a rule, and this rule is called Fleming's left hand rule. Let us see what is Fleming's left hand rule. For this, what we do is we stretch three fingers of our left hand, that is central finger, the forefinger and the thumb. And as you can see, they are stretched in such a manner that they are mutually perpendicular to each other. Now, if they are stretched in such a manner that they are mutually perpendicular to each other, then if the forefinger points in the direction of the magnetic field and the central finger shows the direction of current, then the thumb will show the direction of motion of the conductor. Putting this in words, how do we define Fleming's left hand rule? It states, stretch the forefinger, the central finger and the thumb of your left hand mutually perpendicular to each other. If the forefinger shows the direction of the field and the central finger shows the direction of the current, then the thumb will point towards the direction of the motion of the conductor. This, students, is Fleming's left hand rule.